Hello, welcome to this AWS webinar. My name's Ian Massingham. I'm a technical evangelist with Amazon Web Services located in Europe, and I'm going to be your host for this session, which is a masterclass series webinar focusing on Amazon S3, which we're presenting today in partnership with Intel. And we have one other webinar series that you may be interested in, the Journey Through the Cloud. You can find a link to this in the links panel in the webinar interface and in the video description if you're watching on YouTube. And the Journey Through the Cloud is a solutions-orientated webinar series where we look at how you can apply different AWS services to particular areas of challenge or particular usage scenarios that you might have. So if you're interested in that, take a look at the Journey Through the Cloud webinar series. Other things that you can see in the webinar interface, in the links panel, you'll find a PDF download of the materials from today's session. And it's a good idea to download this, particularly for masterclass series webinars where we have lots of references, lots of code samples, and lots of URLs embedded in the slide where you can find further information about some of the topics that we're going to be discussing in these sessions. So download the materials from the files panel, or alternatively you can access them on SlideShare, once again from the video description if you're watching on demand. One other useful panel that you'll see in the interface is the Q&A panel. We've got a lot of material in today's session, so we may not have time to answer questions at the end. Even if we don't know, you can still submit questions via the Q&A panel, and we will come back to you in email over the course of the next week with answers to those questions. We have our solutions architecture team standing by to help me out providing you with answers. So don't be shy. If you've got any questions, please submit those via the Q&A interface that you can see in the webinar interface there. Also at the end, I'm going to show you some social media links that you can follow to keep up to date with AWS globally and also stay up to date with our webinar program here in UK, Ireland and Nordic region. And also at the end of the webinar, you're going to be able to rate today's session. So please do give us a score from 5 to 1, with 5 being the highest. We'd love to hear your qualitative feedback on the session as well. So if you've got any feedback during the session today, particularly if you think we can improve things and you'd like to give us some guidance as to how we can do that, please submit those feedback notes via the Q&A panel as well. We'd love to understand how we can do better for future customers that might want to learn about Amazon S3 in the future. So that's housekeeping out of the way. Let's move on now because we've got a lot of content today. So this is a masterclass series webinar. It's going to be a technical deep dive today that goes well beyond the basics on Amazon S3, the simple storage service. It's intended to educate you on how you can get the best out of this specific AWS service, showing you how things work and how you can get things done. Before we go deep, we're just going to recap some of the basic characteristics of Amazon S3. So this is a secure, durable and highly scalable object storage service accessible via a simple web services interface. It enables you to store and retrieve any amount of data, and you can use it alone, or as you'll see through the course of the session today actually, you can use it in conjunction with other AWS services. What are the characteristics of Amazon S3? Well, it provides durable infrastructure to enable you to store important data, and it's designed for durability of 11 nines for your objects. So your data is stored redundantly across multiple facilities and across multiple devices in each facility in order for us to achieve that. It's low cost with a pay-as-you-go model, no commitments or upfront fees, you just pay for your usage. And it's also highly available, designed for 99.99% availability of objects over a given year, backed by an SLA and showing that you can rely on it when you need it. And it allows you to optimize across regions, so you can place your data inside S3 in specific AWS regions, enables you to optimize for latency, to minimize costs, or to address regulatory requirements. Security is handled through data transfer over SSL, and a variety now of different options for encryption of your data once it's been uploaded, which we're going to cover in more detail later in the session. We'll also cover bucket policies, how you can manage object permissions and control access to your data using AWS Identity and Access Management. The service is high performance, supporting multi-part uploads, enabling you to maximize utilization of your upstream bandwidth when uploading objects or content into S3. And it's also very high performance in download, enabling you to support high volumes of content access for objects stored inside S3. And it's easy to use, which we hope to illustrate to you during the course of the session today. On use cases, you'll find that S3 is used for a very wide variety of different use cases by Amazon Web Services customers, from backup and archiving to content storage and distribution, for storing the data that drives big data analytics processors, enabling you to decouple storage from compute resources, integration with other services like Amazon's Elastic MapReduce service, the EMR service for running Hadoop workloads inside the AWS cloud. You can integrate that with S3. And similarly, you can integrate with Amazon Redshift, our petabyte scale data warehousing service, once again allowing you to decouple your data storage from your compute requirements. It can offer you a really good opportunity for cost optimization, enabling you to reduce costs and scale your compute resources when you need to in order to meet demand. It's often used for cloud native application data, such as mobile applications where you might want to directly integrate mobile apps with cloud-based storage. That's a common use case for S3. And finally, on disaster recovery, where you may want to keep a secondary copy of data inside a highly durable, secure storage service, so if you need to recover that information in the case of a disaster, you're able to do that in a reliable and available manner. So there's broad usage across a variety of different use cases by customers. So that's a quick intro. How about an agenda for today's session? Like I said, we've got a lot to cover today. So we're going to start off by looking at Amazon S3 concepts and fundamentals. We'll then talk about namespaces and access controls. We'll then show you a demo of how to get started with Amazon S3. And then we'll move into some advanced features, storage classes, encryption and other security features, versioning and cross-region replication, lifecycle rules, and we'll close up by looking at website hosting and then show you some resources that you can use to learn even more about Amazon S3, because that's not everything on the agenda. We're actually not going to have time to cover all of the features that are available in this service during the course of today's session. We'll show you references to some further reading and other sessions that you can watch on YouTube if you want to continue to learn more about Amazon S3. So, concepts. What are the fundamental concepts and fundamental terminology that we use to describe the logical constructs that make up the S3 service? Well, the first is buckets. These are containers for objects stored in S3, and they serve several purposes. They enable you to organize, or us to organize, the Amazon S3 namespace at the highest level. They identify the account responsible for charges, so each bucket is owned by one account and only one account. They play a role in access control, as you'll see later in today's session, and they also serve as a unit of aggregation for usage reporting. Inside your buckets, you have objects, and these are the fundamental entities that are stored inside Amazon S3. They consist of data and metadata. The data portion is opaque to S3. The metadata, that's a set of name-value pairs that describe the object. And the object itself will be uniquely identified within a bucket by a key, which is the name of the object, and also by a version ID. Okay, and keys are important. These are the unique identifiers for objects within a bucket, as we've said. Every object in a bucket has exactly one key, and a combination of bucket, key, and version ID uniquely identify every object inside Amazon S3, and there are trillions of objects stored inside S3 today. You can see an example there at the top of a couple of things. The orange highlighted text to the right hand side of that URL, 2006-03-01/AmazonS3.wsdl, that is the key for a specific object. Okay, and although it looks like it's a directory hierarchy, it's not. The thing, the text before the slash there, 2006-03-01, that is a prefix. It's not a directory structure in the sense that you have a directory structure on a file system. That is just part of the key name, but you can manage and group objects by prefix. And then to the left of that slash, so to the left of 2006, you're seeing the specific endpoint, and doc, which is highlighted there, happens to be the name of the bucket that this particular document is stored in. So that combination, that URL combining the endpoint, which includes the bucket name, together with the key, will uniquely identify an object, and you may have multiple versions of that object as well, which we'll cover in more detail later in this session. The other important construct is regions. This is a geographical region where Amazon S3 will store the buckets that you create, in common really with EC2 regions around the world, and actually many other AWS services that are delivered on this regional basis as well. And you can choose a region, as we said at the top of the session, to optimize latency, minimize costs, or address regulatory requirements. And objects stored in a region will never leave the region unless you explicitly transfer them to another region. So for example, if you're storing objects, creating buckets in the EU West 1 region in Ireland, the objects stored in those buckets will never leave that region unless you configure them to be moved, copied, or replicated into another region. So this can enable you to meet compliance or regulatory demands that you may have to meet, as well as optimizing for latency and minimizing costs. So regions are a very important construct within S3. What about some other fundamentals? Well, it's a web store, not a file system. It offers this highly scalable data storage with access via APIs. It's very fast, both for upload through multi-part upload and also for download. It's highly available and durable, and it's very economical. We're going to look at a couple of these aspects in a little bit more detail now. First of all, we'll take a look at APIs, and you can find a complete API reference for Amazon S3 at awsamazon.com/documentation/S3. There's this page you can see here, and there's a complete API reference there which describes all Amazon S3 API operations in detail, as well as providing many sample requests, responses, and errors. Okay, so you can check that out if you want to learn more about working with the API directly. We tend to find that most customers that are developing applications that make use of S3, though, will make use of the pre-built and maintained SDKs that Amazon Web Services provides. You can find out more detail about AWS SDKs generally at awsamazon.com/tools. And there's full support for Amazon S3 in all of the currently supported SDKs. So client SDKs such as Android, iOS, and browser SDKs, and then programming language SDKs like Java.NET, Node.js, PHP, Python, and Ruby. They all support access to and control of the S3 service from within those programming languages using the SDK frameworks that have been defined. And if you didn't know, we are actually in the process at the moment of working on the creation of an SDK for the Go programming language as well. It's currently on GitHub. We welcome pull requests on that, and you can contribute to development of the AWS Go SDK if you wish to do so. And of course, keep an eye on the AWS blog for news and updates about developer previews and general availability of that new SDK over time. But there is already support for S3 in the current version of the SDK that's been collaborated on GitHub right now. Access via the CLI is, of course, another access mechanism that you have for working with Amazon S3. And you can see here an example of a variety of different CLI commands being executed against an S3 bucket that I've created for demo purposes here. And you'll see there's some commonality here with the commands that are used for working with file systems in the Unix shell. So AWS S3 LS will list the contents, or list rather the buckets that are available to the specific set of AWS credentials that are being used by the CLI if you don't put a suffix on it. And then you can list the contents of a specific bucket by adding a bucket prefix. You can see there S3://AWS-ENM-S3-Masterclass is the name of my bucket, and that will list the contents of my bucket. You can see the first time I do that it's empty. I then copying a file to create an object in that bucket, which is uploaded, and if I list again, you can see that my object has now been created, S3-Masterclass-logo.txt. Can copy that, streaming it into standard out, so you can see the context of my text file there is the ASCII S3 Masterclass text that you can see there. You can delete an object with RM. There's a command to synchronize a directory with a bucket, AWS S3 sync, enabling me to sync my current working directory contents I've used there with the dot into a specific S3 bucket, and then listing those back again, deleting the contents of that bucket using the -- recursive flag to delete everything. And you can access comprehensive help, not just on the S3 command set for the AWS CLI, but actually for any command set for the CLI, just by putting in the command set followed by the word help, and you can list detailed help for specific commands by adding the command before that. And you can see an example there at the bottom. AWS S3 CP help would give me back this, which I can scroll through, and it will give me comprehensive help on the syntax and all the command line flags and options that are available for a specific command. So you can do a little bit of research on that. If you install the CLI, you can read about how the AWS S3 CLI commands can support your specific use case. So jumping back into those fundamentals, the second thing that it's really worth exploring in a little bit more detail is this idea of a web store and some of the differences between having that API-based access and using a file system. And two of the most important differences are the fact that the S3 service is intended for write once, read many use cases. Now, that doesn't mean that it's a worm device in the traditional sense, where you might have either physical or digital locking of your media so that you can only write it once and read it many. It means that in S3, the optimal access pattern is that you reading your objects much more than you're writing them. Okay, and we'll talk about that why that's the case later in this session. So this write once, read many architecture, well, there's obviously a platform underneath S3, and I just want to talk to you briefly about how we provide for durability and availability within that platform. And S3 is constructed using availability zones within a specific AWS region. You can see a representative architecture here where we've got infrastructure to support S3 distributed across a couple of availability zones, or AZs. And when you come to write an object, you're hitting one of those load balancers, you're hitting an API endpoint, and that object is going to be stored redundantly across storage in at least 2 availability zones. So your information is replicated and protected. And once that's happened, indexes will be updated. Once again, that indexing process again is distributed across those multiple availability zones. And then if for any reason there's an issue with any of the infrastructure components that support the service, you'll see that redundancy is built into the platform, and there are alternative paths available both at the access tier, the API endpoint tier, and in the indexing and storing as well. Indexing and storage as well. And if for any reason that entire availability zone becomes unavailable, the whole system is replicated and failover can take place into a second AZ, ensuring that your data is available with good availability and a very high durability characteristic. So that's how the write once, read many architecture is built. What about consistency? This idea of eventual consistency, what does that mean? Well, for new objects, there is strong consistency across all regions apart from the US standard region. This means that if you're writing a new object anywhere else in the world, we're synchronously storing your data across multiple facilities before we return a success code. Okay, that gives read after write consistency. In the US standard region, things work slightly differently. You can find out more details about that if you take a look at the URL that you can see at the bottom of the slide. But in essence, in the US standard region, requests will be routed to facilities in Northern Virginia and the Pacific Northwest using network maps, which means that you have eventual consistency on new object storage as well as on updates and on deletes. And in the case of updates and deletes, things happen the same around the world. So if you write then read, you may find that the reported key does not exist. If you write then list, it may not include the key in the list. And if you overwrite and then read, old data could be returned. But of course, the system will eventually reach a state of consistency. That normally happens very quickly. In deletes, same circumstances. So if you delete and then read an object, you could still find the object is there and you get old data. And if you delete and then list, you could find that deleted key may be included within the list. But over the course of a very short period of time, consistency will be achieved, and you'll find that the system is in a consistent state, and updates and deletes both return the expected results. Okay, so that's the eventual consistency model. Moving on to talk about namespaces. As we said earlier, a bucket name plus an object name, the key, will be globally unique, and you can essentially store multiple buckets within your account, up to 100 today. And within those buckets, you can store objects, and those objects can take a variety of different formats. Here you can see examples of us storing PowerPoint and MP4, and we've got a prefix on that MP4 there, the vid prefix. We're storing some shell scripts and some credentials in another bucket that we're going to use for bootstrapping. At least that's what the bucket name looks like. We're going to use those objects for. And then we've got a DNS style entry, AWS-examples, which we'll come to later. And we've got some HTML and a logo stored in there. So object keys need to be unique within buckets, and there are some restrictions. You have a maximum of 1024 bytes, UTF-8 encoded. And that 1024 bytes includes any path prefixes in quotes, because they're not really paths, they are prefixes that you can use to organize your information within a bucket. And you can see here an example of an object key. So we've got several prefixes here: asset/js/jquery/plugins/jstables.js. That's an example object key that defines a specific object. In this case, it's likely to contain some JavaScript. So throughput optimization, this is quite important. S3 automatically partitions your objects based on the key prefix. So here we can see an example of data that's been stored for a mobile gaming use case. And we've got incrementing game IDs here that we're using at the beginning of our prefix, and there's a little bit of a potential issue here, which is that, as you can see, all of our object keys start with the same character, and all of those object keys would end up in the same partition, the my new game /2 partition. And that could lead to some performance issues. If we've got a large amount of data, but we've got very frequent access to, say, the most commonly, most recently stored objects in our set, then that particular partition could find itself under higher than necessary usage. And this is something that you can address by aiming to get better distribution of your object keys. You can see what we've done here is we've reversed the game ID, which gives us better key distribution, and now our objects fall into 3 partitions, /7, /8 and /9, and that will help us optimize throughput to those objects by ensuring that they're well distributed across the key space. So that's a little trick or tip that you should bear in mind when you're looking to organize, specify and lay out the object keys for the objects that you're going to store in a specific bucket. Access controls. This is another very, very important part of Amazon S3, and actually a real strength for this service. There's several different options available to you, policies that you can use, ACLs, and the use of IAM, Identity and Access Management, that you can use to define rules that will specify who can access which aspects of your S3 service. And this means that you decide what to share by applying these policies to buckets and objects. We'll just run through the 3 different options that are available for you now. The first is IAM policies. This gives you fine-grained control over who can do what via the S3 API. You can apply policies at the role, user and group level. And this is a service that's been around a long time. I dug back through our archives and found the launch announcement for IAM, and that was posted on the 2nd of September 2010. So it's 4.5 years old now, this service. And it provides a comprehensive set of tools for controlling access to all AWS API actions. You can find out more at awsamazon.com/IAM, of course. And here you can see the IAM console. We have here set up a specific group for access to S3 within my demo account. You can see that group's called S3-admins. And we've attached a managed policy to this group called Amazon S3 Full Access. Managed policies are policies that are defined by Amazon Web Services for commonly used policy requirements, which you can attach to groups or users within your IAM console, and therefore provide specific permissions to those users. And managed policies have standard IAM policies attached to them, and you can see that the managed policy that I've attached here allows the group or user that it's attached to perform any action on any resource within the S3 API namespace. So this is a very permissive policy, but only within the S3 service. A user in this group would be able to perform any action on S3, but no action on any other aspect of the AWS API for this account. And this is the policy that was applied to the user or credentials rather, that I was using in the CLI walkthrough that I showed you earlier. So given full access to work with S3, but if I'd attempted to execute any other command from that console, that would have resulted in a permission denied response. You can use IAM to control who can do what, not only at the service level, but also, for example, as you can see on the left there, in specific buckets or specific prefixes. Second tool that you have at your disposal is bucket policies. Once again, fine-grained control. You apply these at the bucket level within S3. And this allows you to incorporate user restrictions without using IAM. So it's very useful for things like permitting public access to resources. A good example of that you can see here, where we're granting read-only permission to an anonymous user to access any object in the example bucket using just the get object action. This would be common if you were going to configure your bucket as a website, as you can see later in the session we will do, and you want everybody to be able to read objects in that bucket. This is exactly the policy statement that you would use to configure your bucket for that kind of access. this explains precisely what we've done here. So we've set our allow policy in the effect. We've set a principle of star, which means the policy applies to everyone. We've allowed the S3 get object action. We've specified that in the actions property. And then we've specified in the resource property the specific bucket, and in this case the prefix of star, which means all objects in this example bucket are going to be available to those principles that we've specified there. Obviously very useful, as I've said, if you want to configure a bucket for access as a website. Of course, you can do way more than this with bucket policies. Here's a slightly more complex example. In this particular example, we're restricting access to specific IP addresses. So a little bit more of a permissive policy. We're allowing anyone to do anything in the example bucket as long as they come from the subnet specified 54.240.143.0/24, except one specific address, which is 54.240.143-188. That specific address is blocked and not permitted access. So you can see you've got very fine-grained control to implement policies which meet your specific use case needs if you make use of bucket policies. Here are some other example use cases for bucket policies. You may want to grant permissions to multiple accounts. You may want to restrict access to a specific referrer. Maybe you only want images within a bucket to be linked from a specific web page that you're going to refer from. You don't want use of those images by third parties. Well, you might restrict access to a specific referrer if you wanted that. You can grant permission to an Amazon CloudFront origin identity, which we'll talk about later. Adding a policy to require MFA authentication, or granting cross-account permissions to allow another AWS account to upload objects into one of your buckets while you retain full control over all aspects of that bucket. So you can find out more about those policies and actually some other examples as well if you check out the URL that you can see at the bottom of this particular slide. And then lastly, ACLs. These have been around a little bit longer. They predate IAM and bucket policies. They're more coarse-grained. They enable you to apply access control rules, but there are some limits in managing permissions using ACLs. You can only grant permissions to other AWS accounts. You cannot grant permissions to users in your accounts. It may fit some use cases, but I think the recommendation today would be, unless your use case is quite simplistic, then making use of bucket policies is a better option. Okay, so that concludes a section on the fundamental concepts and service components within Amazon S3. Next thing we're going to do is show you a quick demo, walk you through getting started on the console, creating buckets, uploading objects and working with objects. So let's do that right now. So here we are in the AWS console, and obviously we're going to be working with the S3 service today. So we're going to go into the S3 subconsole, and in common with most AWS services, if you don't have an instance of that service configured, when you access the console, you'll be provided with some documentation, kind of wizard-based walkthrough, and you can see some simple description about S3 here, explaining some of the characteristics of the service, and providing some at-a-glance feature capabilities as well. So we're going to create a bucket here, and we're going to create a bucket in Ireland. Now remember that bucket names need to be globally unique, so I'm going to use my AWS-ENM prefix, which I use to organize buckets in all of my accounts, so that I know that they're going to be, well, stand a better chance of being unique, let's say. So I'll create that bucket, and that will just take a second, and we've now got a bucket here that you can see properties on. Obviously what we want to show here really is the process of uploading an object into that bucket. So if I click on my bucket, you'll see that my bucket is currently empty, and I'm going to upload an object here using the actions menu inside the console. So adding files, and I've got several files here. I'm going to upload a file that contains the S3 Masterclass logo. Start upload, and you'll see that in just a second that object's been uploaded into that bucket, showing the storage class size and modification date. You can actually click on that object to view it as well. And this is the object that we just uploaded, our little bit of ASCII. Let's make that a little bit bigger. So how can we make that object accessible? By attaching a bucket policy so that we're going to be able to access that object from the web. Well, if we take a look at the object properties, you'll see that the link for that object is available here. And I'm going to open this in a new tab in my browser. And you'll see that the URL that we've got in our browser here doesn't have the authentication details in the query string that are required to provide us with access to that object. And that's in contrast with the URL that we've got here, which you can see includes all of the authentication details that are required to provide access to the object that we uploaded. And the way to fix this, to make the objects publicly accessible, is to apply a bucket policy. And we'll take a look at that now. So if you go back into the bucket details in the console and take a look at the properties for this bucket, you'll see there's a specific section here on permissions, and we can apply or add a bucket policy here that will enable us to make the contents of our bucket public. So we're going to do that right now. We'll copy and paste a policy that will fix this issue for us, which you can see here. And we're going to make the resource AWS-ENM-S3 Masterclass / available to principal star, which is anyone, for the action S3 get object. So if I save that and then reload our object using the same URL that we had previously, you'll see that object's now available. That's how you can make an S3 bucket publicly accessible, enabling it to serve content to any users out on the internet. So that's a very, very quick demo of getting started with Amazon S3. We're going to jump back into the slides now and take a walkthrough of some of the more advanced features of the service. First feature we're going to take a look at is storage classes, and this provides a mechanism for you to choose the level of durability and also the cost of storing data inside S3. And you have three options available to you, two of which are native within the S3 service. So this is the standard storage class, which provides that 11 nines durability and 99.99% availability of objects over a given year. And that's designed to sustain the concurrent loss of data in two facilities, implying that data is replicated across at least three facilities, of course. And then you have reduced redundancy storage. This can offer a lower cost mechanism for storing data that is either less critical or perhaps more commonly can be recreated from, say, a master data set that's stored with standard level durability. So this is commonly used for things like transcoded media files, where you might need to create multiple versions of a media file in different bit rates. You have a master, your perfect quality copy, which you store in standard, and then you derive the transcoded versions and store them in reduced redundancy storage, or RRS as it's sometimes known. And then we have a third class called Glacier, which is suitable for archiving data. It's intended for write once, read never use cases where data access is very infrequent and a retrieval time of several hours is acceptable to you, but you still have to keep that data. It's commonly used for compliance with regulatory standards, where you may need to keep transaction data just on the off chance or occasion that a regulator needs access to it at some point in the future. And that can offer a low cost archive tier for that particular use case. And pricing is important here, obviously. So you can see these example prices. These are correct as of the date of today's webinar in the EU West 1 region in Ireland. Standard storage for your first terabyte, you're looking at 3 cents per gigabyte per month. RRS, you're looking at 2.4 cents. And Glacier, you're looking at 1.1 cents. So Glacier is about a third the price, and RRS is significantly reduced in its own right. And moving objects between storage classes can be achieved in a variety of different ways. Here you can see how it's done on the CLI. You can specify the storage class of an object when you upload or create it by using the ---- storage class command line flag, specifying reduced_redundancy for reduced redundancy. Standard is the default, but if you wanted to specify that, as you can see here, this example of moving or changing the storage class of an object, you're copying the object into the same key name in the same bucket, and you can use ---- storage, that's class again, either standard to move an object from reduced redundancy to standard, or reduce_redundancy to move it the other way. You can also, as you might have seen earlier when we looked at those object properties during that short demo, change the storage class in the console by clicking that radio button for reduce redundancy, and that will move your object into the RRS storage class. You can achieve the same thing with the SDKs. Here you can see an example using the Python Boto SDK for AWS for Python to create a new connection object to S3, to create a new bucket object by getting the AWS E&M-S3 Masterclass bucket, and then we're using copy key to essentially do the same thing which we did on the CLI, which is to copy a pre-existing object into a new object with the same key in the same bucket and specifying the modified storage class there for reduced redundancy, as you can see. What about Amazon Glacier? Well, we're going to come back to Glacier later in the session when we talk about lifecycle management. Encryption. So there are several options now for encryption inside Amazon S3. The first is to say that data in transit, well, it's secured by default if you use the SSL encrypted endpoint and upload data using HTTPS. Alternatively, you can pre-encrypt data before uploading it using a client encryption library, such as the Amazon S3 encryption client, which you can find more details about using the URL at the bottom of the page here. And you can use a mechanism like that to encrypt your data before you actually store it in S3. In the case of the client library, data encryption is done using a one-time randomly generated content encryption key, or CEK, per S3 object. The encryption materials specified in the constructor will be used to protect the CEK, which is then stored alongside the S3 object. Okay, so that's one mechanism that you can use for encryption of data before transmission. You can also secure and encrypt data at rest, and you have three different options for this. The first, and the one that's actually been around the longest, is Amazon S3 server-side encryption. This enables you to automatically encrypt data on write and decrypt it on retrieval. Uses AES 256-bit symmetric keys. And you have three different ways to manage those keys. This is the original version. This is the SSE with Amazon S3 key management. Okay, here Amazon S3 will encrypt your data at rest, and it will manage the encryption keys for you. So encrypting each object with a per object key, encrypting the per object key with a master key and storing those encrypted keys, and then monthly rotating that master key, storing those master keys as well. So that's something that you can simply turn on by using an option inside the S3 console, the command line, or one of the SDKs. And you don't have to do anything on key management. We manage the keys for you in that scenario with SSE-SE. There is a second option, which is customer provided keys, SSE-C. In this case, we don't store the encryption key anywhere. We discard the key immediately after we've completed your requests. Okay, so you include the encryption key in your upload request. Amazon S3 encrypts the object using that key and securely stores that data. And we discard the key. And then to retrieve the object, you provide your custom encryption key with the read request. We will then decrypt the object as part of the retrieval process and then immediately discard the key again. So in that scenario, you're managing the keys. You're also managing the relationship between keys and objects. And then thirdly, this is the newest option, SSE with AWS Key Management Service, or SSE-KMS. This scenario involves Amazon S3 encrypting your data at rest using keys that you manage but that are stored in the AWS Key Management Service. And this provides several benefits, including the fact that there are separate permissions for the master key, which provides an additional level of control, as well as protection against unauthorized unauthorized access for your objects stored in S3. KMS provides an audit trail so you can see who's used what key to access which object and when, as well as allowing you to view failed attempts to access data from users without permission to decrypt. And it provides further additional security controls to support your efforts to comply with standards such as PCI DSS, HIPAA, or other US federal government requirements. So if you want to take a look at KMS, it's a separate service in its own right, which is integrated with S3. It's also integrated with a variety of other AWS storage services, and that might be a good option for you if you've got particular demanding compliance and audit requirements. Okay, so check that out if you want to learn more about that. There are additional security features which we're not going to cover in a lot of depth during today's session due to time constraints. Audit logs, which means that S3 supports logging of requests made against your S3 resources. You can configure your S3 bucket to create access log records for requests made against it. These access logs will capture all requests made against the bucket or the objects in it and can be used for auditing. If you want to learn more about that, check out the access control topic in the S3 developer guide. There's more details on that there. And then we have multi-factor authentication for delete. This allows you to enable MFA delete on your S3 bucket. and that means that you can only change the versioning state of your bucket or permanently delete an object version when you provide two forms of authentication together, namely your AWS account credentials and then a concat of a serial number, a space, and the 6-digit code on an approved authentication device. And this can be a soft token running on a phone, or it can be a hard token like a Gemalto token, which can also be used for other MFA authentication actions with your AWS account. So this is, in summary, integrating MFA with S3 versioning state and object deletion requests via the API. Again, there's more details about that in the developer guide for S3. And then lastly, one that we are going to just focus on for a few minutes is time-limited access to objects. This is using a feature called query string authentication, which once again, you'll have seen during that demo when I moused over that middle tab to illustrate how we were authenticated. You'll have seen the URL there was a pretty lengthy URL, and that's because it included query string authentication details to enable us to access a time-limited URL for a specific object. Okay, and they look like this actually. So here we're looking at an example of a URL that includes query string authentication. And this one's been generated for us. It includes a signature, an access key, and an expiry time, as well as an endpoint and an object name. This will uniquely identify that specific object, of course, as well as authenticate this particular request and allow access to that object as long as the authentication details that have been provided are indeed valid. And you have again a variety of different options for generating these time-limited signed links. Here are some examples in Python showing once again creation of an S3 connection object and then calling the generate_URL method. And the first parameters that you can see here is the link lifetime in seconds. So in the first example, we're creating a time-limited URL that's going to last an hour. And in the second example, we're creating a time-limited URL which is going to last 30 seconds. And here we're also forcing the creation of a non-SSL link. Okay, if you, of course, try to access an object where those details have expired, you'll be presented with this familiar authentication issue, access denied, and your request will be marked as expired and you will not be able to access the object. This is used quite often in scenarios such as software downloads or other applications where you might want to restrict the length of time that users have access to an object. And of course, you can combine that with things like jQuery in the browser to redirect users onto short-lived links to give them access to downloads without any opportunity for them to see the error message that you can see there if their link has indeed expired. Next, we're going to take a look at versioning and cross-region replication. Versioning is a feature that's been around within S3 for a long time. Cross-region replication is very new, and the reason these topics are together is because you must turn on versioning if you're going to use cross-region replication, so they are linked. Okay, and we'll come to cross-region replication in a moment. First of all, on versioning, you can configure this at a bucket level, and this allows you to store all versions of all objects stored within your bucket. Okay, and this can allow you to recover from unintended user actions or application failures by rolling back to a prior version of an object. You may also want to configure this for auditing or compliance reasons. And the process for doing this is very simple. Via the console, you'll see in your bucket properties, underneath, probably saw this earlier, in fact, underneath the permissions, you'll see a drop down for versioning. And if you pop that down and click enable versioning, you'll get a pop-up warning telling you that version enabled buckets store all versions of your objects by default. You can control costs using lifecycle rules, e.g. by deleting older versions automatically. And this is important because your costs will be increased if you're using versioning, because you're going to have multiple copies of each object stored within your bucket, multiple versions stored within each of your buckets that you have versioning turned on. Once you've turned it on, you'll see in the console the show and hide version option become visible for buckets where versioning is turned on. You can see here we've turned it on in our example bucket, uploaded several versions of the S3 Masterclass logo.txt object, turned on versioning, and prior versions are shown for us there together with version IDs, the sizes, and the times at which those specific versions were created. And of course you can work with versioned objects via the CLI. This uses a different CLI command. This uses the AWS 3 AWS S3 API CLI command, which has additional functionality over the more simple AWS S3 command. Here we're using the list objects versions subcommand in the bucket that we used earlier, and you can find much more detail about this particular API CLI command, the AWS S3 API CLI command, if you go to the URL at the bottom of the screen. But if you run this command, you'll be presented with output that looks like this. You'll see this is very similar to what you saw in the console previously, and you can then use the get object command on the AWS S3 API CLI command to get a specific object by referencing the bucket, the key, the version ID, and in this case we're copying that object into a new file called version.txt. You can also work with object versions from the various SDKs that we provide. Here you can see further examples using Python Boto, once again creating a connection object, creating a bucket, and then listing the versions within that bucket using the list versions method, and that will create a list of the versions available within that bucket, and then we're printing those out, obviously inserting a space in the concat of the string there. Once you've done that, you can then get a specific object version by passing a version ID as a parameter into the get key method for that bucket. You can get the contents of that key as string, and you can also generate time-limited URLs for specific versions of objects as well, which you can also see in this quick code sample here at the bottom, once again calling the generate URL method on that key object to do that. So that's a pretty quick walkthrough of working with different object versions. As I said, cross-region replication is a related topic, and this is automatic asynchronous copying of objects across buckets in different regions. Okay, to activate this feature, you're going to add a replication configuration to your source bucket, providing information such as the destination bucket that you want the objects replicated to. You can have the whole bucket replicated, or you can just replicate a subset of objects with specific key name prefixes. So for example, just replicate objects with a key name prefix tax/, and this would replicate objects like tax/doc1 or tax/doc2, but not any objects which had other prefixes such as legal/, for example. Object replicas are exact replicas of objects in the source bucket. They have the same key names and the same metadata, same creation time, same owner, same user-defined metadata, same version ID, storage class, everything else, and Amazon S3 encrypts all data in transit across regions using SSL. Here's a quick walkthrough of doing this on the console. So first thing we're going to do is create a second bucket. Here we're going to be creating a bucket that will have its content stored in Frankfurt. We're sticking a suffix on the end of the bucket, -FRA, to identify it as separate. And you can see then that we have two buckets listed in our console. And if we go into the properties for our original bucket, the one that's located in Dublin, you can visit the cross-region replication section of the properties and enable cross-region replication. Note that the destination bucket must also have versioning enabled. Then need to create or select an IAM role to enable replication after you've specified the region and bucket that you're going to target. And an IAM role will automatically be created for you with the correct policy template. I've expanded that here so you can see precisely what the policy document is, but this is all created for you automatically through the console. Once you've done that, click allow. And the IAM role will now have been created for you, and you can see the selected IAM role is referenced at the bottom of the properties there, and it tells you that cross-region replication is now enabled on this bucket. So if we jump back into the console, I'm going to copy a new object into our bucket using the command line that you can see there, and then if we then list the contents of that second bucket in the EU Central 1 region, you can see that our Masterclass S3 logo has been created automatically in that second bucket using the cross-region replication feature. So that's very, very simple to set up. There's obviously a variety of different reasons that you might use that. One, of course, is taking a second copy of your data for regulatory or compliance reasons, just to protect it in another region if you need to do so. But you can also use it for things like accelerating bootstrapping. So if you're bootstrapping large fleets of EC2 instances using artifacts or scripts that were located in S3 buckets, and it's cost effective to have those in the same region as the instances, and you could use this mechanism as part of your CI/CD toolchain for making sure that all of your bootstrapping assets were located locally to your instances rather than being remote for them. So that's another use case there. Lifecycle rules. So this is a mechanism for automatically managing objects during their lifecycle, doing things like object deletion, permanently deleting objects from S3 after a certain period of time, or commonly also moving objects from S3 to Glacier for archiving purposes. And I did say that we would come back to Amazon Glacier, and here we are. So it's a low-cost archive storage, enabling you to archive very large amounts of data at very low cost. You only pay for what you need, again, with no minimum commitments or upfront fees. And you've seen that it starts at roughly a third of the price of Amazon S3's standard storage class. It's secure, it has the same durability characteristics as S3, offering 11 nines of durability. It's also a regional service. And you've got this integration through lifecycle policies. So the durability and cost-effective nature of the service are combined with these lifecycle integration features. This enables you to do things like this. So let's just say we've got some log data stored in an S3 bucket called logs. We want to keep that for a period of time. Then we want to automatically expire it, so we don't need any administrative action or any system, any external system to expire those objects for us. We can just set a threshold, say 30 days. And after that 30-day period, those objects expire and are deleted automatically. And then we've got a second set of data called transactions. And what we want to do here is transition these transaction logs into Glacier, because we want to keep these for a longer period of time. So after a 30-day period for the transactions bucket, we're going to effect an object transition to Glacier. That'll store the objects in our long-term archive storage on Glacier at lower cost. And if we want to retrieve those objects, we can request restoration, requesting that the objects be held for a certain period of time. We have a 3 to 5 hour delay while those objects are restored from Glacier back into S3 RRS. This is the reduced redundancy storage class you remember we talked about earlier. And then those objects are available for us to access for the period of time that we specified in our request. And you can configure this in the console by using lifecycle rules. So here's an example of a console screenshot. You can see the bucket properties have a lifecycle section in them. You expand that, you have the option to add a lifecycle rule. So we select that. And then we're asked what the rule target is. We're going to apply this to the whole bucket, but you could equally well apply that to a prefix. As you saw a second ago, the logs prefix or the transaction prefix might be things that you may use. And we'll apply this to our whole bucket. We want to archive and then permanently delete objects in this bucket. Once you've made a selection from that drop-down menu, this additional panel will appear asking you to specify, in this case, after what period of time you wish to archive to the Glacier storage class, and also after what period of time you want to permanently delete the objects specified in the scope earlier. So once you type in those numbers, in this case we've selected 90 days for archive and 900 days for permanent deletion. You can then review your lifecycle rule settings. In our case, we've got a warning here just instructing us that smaller objects when transitioned to Glacier might result in cost increases. This is because I just have sample data in my bucket, which is very small in size. But if the average size of your objects was larger, you would not see that object that warning appear. If you preview, you're then asked to name your lifecycle rule. Once you've done that, you can create and activate the rule, and you'll see back in the bucket properties within the console, your lifecycle rule now appears, and you can edit or remove it at any point that you wish to do so. And that's it, basically. You can also, of course, configure lifecycle rules using APIs, CLI, and SDKs, and here we're using the .NET SDK to create new lifecycle transition objects, transitioning data to Glacier after 1 year by setting the days parameter to 365 there. And similarly, we're creating a lifecycle rule expiration for 3,650 days, which is of course 10 years. So you can control lifecycle rules through a variety of different methods, as you might expect. Once you've got objects that are transitioned, and you can see an example object here that's been transitioned to Glacier, I forced this by setting a very short migration period of 1 day. You'll see that object's been transitioned and it's in the Glacier storage class, which means it's not directly accessible. But if you want to make it accessible from the console, just click on the object. You'll see this initiate restore option has appeared in the menu. You can select that, and if you do so, you'll be asked how long you wish to retrieve the object for. Enter a number of days here and click on OK. and the object properties will then show in its details that restoration is in progress from the Glacier storage class. That'll take 3 to 5 hours, as I said earlier. And once that's completed, you'll see that your object then becomes marked as restored and is available for view and download from the RRS storage class, the reduced redundancy storage class for you. So that's working with Glacier through the S3 console. Last thing we're going to look at in detail is website hosting. And of course, you'll have seen before making content publicly accessible, as I did with my ASCII file with that S3 Masterclass logo in it. It's very simple. And that means that you can host an entire static website on S3 for very low cost. And it provides a highly available and extremely scalable platform for hosting static content, reliably serving content. You just don't have to worry about peaks in demand or scaling your infrastructure. There's a ton more information about this. If you visit that URL that you can see at the bottom here, it'll give you a complete walkthrough for hosting custom domains on S3. But very quickly in the console, you'll have noticed earlier, I'm sure, there was a static website hosting drop down in the bucket properties, which provides details of the website endpoint that you can use to access your bucket as a website. And if you tick or click the Enable Website Hosting Radio button, you'll then be asked to enter the name for index and error documents, which we've done here as index.html and error document and error.html. And serving content is then as simple as just placing objects with those keys into your bucket. And when someone hits or you hit the website hosting endpoint, you'll be served up the default document, and if you try to access a document that doesn't exist or an object that doesn't exist, you'll get the error.html document in the case of this configuration. You can also configure redirects, so get your bucket to issue redirects to another domain name, which can be helpful in configuring root domain website hosting, which I'm going to show you in a second. And naturally, you also need a bucket policy, as we showed you earlier, to allow anonymous users to access objects within your website hosting bucket. Hope you noticed that the endpoint was slightly different, and you must use the website addressing notation that you can see at the top of this slide, not the normal addressing notation that you can see at the bottom. And you can combine that with DNS records hosted in Amazon's Route 53 service to enable you to issue redirects and manage your domain names in a very tidy and integrated fashion. So here we've got a couple of buckets that we're working with. One's called www.aws-example.es and the other one is called aws-example.es, and we want to serve our content from the second one, from aws-example.es. Keep our browser URL bar clean and tidy. So I'm going to put content in that bucket, an index.html and an error.html file. I'm going to set up a website redirect on the first bucket with the www prefix to redirect over onto the bucket that doesn't have the prefix. I'm going to use Route 53 to set up an A record alias to an S3 website, which will result in people that enter aws-example.es in their browser being served content out of that bucket, serve that index document or an error document if they're trying to request an object that doesn't exist. And then we're going to put a CNAME for www.aws-example.es over to the bucket that has the redirect on it, using once again the website hosting endpoint for that bucket, and that will give us this result, our index.html file served up regardless of whether or not you put the www prefix in front of aws-example.com. That's live. You can check that out if you want. It's actually working at the moment, so try both options and you'll see the redirect works beautifully. And as I said, for more details on that, check out the URL at the bottom of this slide. So just to quickly summarize what we've talked about during today's session, we've covered a lot of content there. S3 provides developers with a secure, durable and highly scalable object storage service. It can be used alone, it can be integrated with other AWS services or third-party tools and services. And it's cost effective for a very wide range of different use cases, from cloud native applications through to archiving and DR to analytics. As I said, there were a few things that we just didn't have time to cover in this session today. It's a little bit ironic that a service called the Simple Storage Service actually has so many features that you can't cover them all in an hour-long webinar. And we're really out of time today, so not a lot of time for questions. If you do have questions, please submit them via the Q&A panel, and our team will come back to you over the course of the next few days. Things we didn't cover: Amazon CloudFront, our content distribution or content delivery web service, is tightly integrated with S3. It allows you to scale S3 delivery globally and offer good and consistent content delivery performance to users all over the world using 53 endpoints around the world. So check that out at awsamazon.com/cloudfront. We didn't talk about a new feature called S3 event notifications that allows you to trigger event notification messages when changes happen to objects stored within S3. You can use this to trigger workflows, alerts, or other processing, sending notifications through Amazon SNS, our simple notification service, or our queuing service, SQS, or delivering them directly to AWS Lambda. More details on that at the bottom of this slide. And AWS Lambda itself is another topic that we didn't cover. It would be good to cover that in depth, but you could probably spend an hour just talking about this service. This is a compute service that allows you to run code in response to events and automatically manages compute resources for you. One of the event types that is supported by AWS Lambda is S3 event notifications. It allows you to trigger a cloud function written in JavaScript today and soon in Java also that will automatically provision an execution environment for the code that's defined within your function, working with metadata and of course with AWS object or Amazon S3 objects if you wish to do so. So a very powerful tool for building serverless backends, IoT applications, dynamic ETL applications, and servicing many other application use cases as well. So check that out at awsamazon.com/lambda. Further resources that you can use to learn more about Amazon S3, of course, awsamazon.com/S3. That collects up much of the documentation and resources that we've talked about today in one place. There's a getting started guide there. There's a very helpful video that I found on YouTube from AWS reInvent 2014, Amazon S3 deep dive and best practices, which includes lots more detail on event notifications and AWS Lambda. So you can consider that a companion to this webinar really, and something that you might want to take a look at if you're interested in any of those services that we didn't have time to cover. And of course there's comprehensive documentation about Amazon S3 on the AWS documentation site that you can see there at the bottom. If you want to continue to build your skills in AWS, why don't you check out our training options at awsamazon.com/training, learn about self-paced labs, also learn about certification options for AWS. I'll just close up by thanking you for giving us your time today and joining this session. Hope that's been useful. We did cover a lot of material today, so hope that didn't overdo it really in terms of depth. There's a lot of content in this session. Hope you'll download the slides from the files panel. Hope you'll check out the additional resources that were provided there at the end. I hope you'll follow us on these social media accounts so you can keep up to date with AWS here in the UK and Ireland, and also globally at AWS_UKI and at AWS Cloud. We're not going to have time to answer questions during the session today, but my colleague's going to switch this webinar into Q&A mode. I'd like you to spend just 30 seconds and give us a rating from 1 to 5, with 5 being the best. And if you do have any questions at all, please do submit those using that Q&A panel, and our team will come back to you over the course of the next few days with answers to any questions that you submit. Thanks again for joining us today. I hope to see you on another AWS webinar very, very soon. Bye-bye.